Yeah, good morning, and welcome to the second day of OSMC, sorry. And who have slept more than 3 hours? One, wow, okay. Okay, let's start with Roland from Colorado and with a talk about Monasca, and it's an OpenStack as a service monitoring thing.
Oh, thank you.
Please, go ahead.
Okay, so title of the talk is Monasca, Monitoring and Logging. I added that logging part as a service at scale. So I'm Roland Hochmuth, and despite my German-sounding name, I'm not from Germany. I'm from Fort Collins, Colorado. So it's a pleasure to be here. I thank the organizers for inviting me to present here, and it's been a great experience so far. Very nice conference. Oh, and I work for Hewlett-Packard Enterprise. I tend to be kind of wordy on my slides because if I don't put it on the slides, I'll forget it. But I'll try and touch on the main points as well. But my agenda today is to describe more or less how to build a highly scalable monitoring and logging as a service platform. And so I'll kind of go over some of the architectural and design principles that we used in Monasca. I'll talk about scale and high availability. I'll also talk about the Monasca server itself and try to provide an overview of that and cover the features, the API, and time permitting, we'll do a demo. I have a lot of slides to go through, but I do have a little demo at the end if we make it there. Okay, so first, principles. I just want to make sure that we're all on the same page with some definitions. What is monitoring as a service? And so that's the as a service part. That's the new part there. And a lot of people are familiar with services like Amazon CloudWatch, Datadog, New Relic, Librado, and Loggly is one that does logging, and there's many others. So it's typically a monitoring or logging solution that's deployed as software as a service. It's usually run and hosted by a web services company. It has a first-class, preferably RESTful HTTP API. It supports authentication, multi-tenancy, and multi-tenancy means that I can take my data and I can have users come into this service and all their data is stored under their account or their tenant. It can provide self-provisioning to users and tenants of the service, meaning that the user or the operations group doesn't have to deploy it themselves. It's typically designed to be highly reliable and operate at scale or massive scale. And it's typically run by an operations team doing full-out web services. So a highly specialized team is usually running this sort of software. Okay, so who's familiar with OpenStack in the room? Okay, not quite half. Okay, so what is, I'll cover this. What is OpenStack? So OpenStack is a cloud operating system that controls large pools of compute, storage, and networking resources. A better way to probably think about it, which is not a definition, but it's an open source alternative to Amazon Web Services, Microsoft Azure, Google Cloud, and other options that are available. It can be deployed in both public and or private clouds. So a lot of OpenStack momentum these days is in the private cloud, where you see a lot of enterprises deploying it, or even web services company using it internally. But there are public cloud deployments of OpenStack as well that are out there. Okay, so what is Monasca in all this? So Monasca is an open source monitoring and logging as a service platform for OpenStack. It's the official monitoring as a service project for OpenStack. So we are governed under the OpenStack governance as part of what they call the Big Tent. In terms of dependencies on OpenStack, there's not a huge number. The one that is kind of a dependency today, although it's a loosely defined dependency, is on their identity service, which is called Keystone. And so Keystone does our authentication, and we submit auth tokens to Keystone, and assuming it's validated, then we allow the HTTP requests that are coming into our API to be handled and processed further. Okay, so I won't be covering a lot of Keystone today. That's almost it, but that'll probably be mentioned a couple of other times. Okay, so we are a microservices message bus architecture. I'll have some slides later that will talk about that. We're a first-class RESTful API, meaning that the API wasn't added after the fact, and it was built in, designed in from the start around the API. And everything that we do within Monasca occurs via the API. We're primarily a push-based metrics. In the world of metrics, there's the two religions. There's the push-based, pull-based. Who's a pusher? Who's a puller? There's two pullers, no pushers. Okay. Raise your hand quick. All right, so Monasca's push-based. And for those familiar with Prometheus, Prometheus is pull-based. One thing that we've been focusing on is consolidating both your operational monitoring and monitoring as a service and metering and billing and other solutions. I used to work on HP's public cloud when we had one. I did DevOps, and I worked on their monitoring systems. And Monasca is largely a outcome of that development. We, more or less, when we did our public cloud, we had 3 monitoring systems. We had a fairly large team, around, let's say, 14, 15 people doing all this. And we had 3 monitoring systems. We had our monitoring as a service. We had an internal metrics processing system, and which I was responsible mainly for that one. And then we had Nagios. And after we got done deploying all of that, we weren't very happy because we had 3 sub-teams. No sub-team knew about a whole lot. We knew about it, but we didn't know how to really operate the other team's infrastructure. That created a lot of problems. We were all on call all the time, pretty much. Even though we had a very large team. And it was very complicated, and we wanted to simplify that. So Monasca is around consolidating, meaning instead of running multiple monitoring systems to handle all these different use cases, we wanted to deploy a single system to handle them all. And we think we've been largely successful at doing that. It's designed for elastic cloud environments and deployments. So elasticity means that these environments can change over time. New services, new nodes are added, they're removed. And so Monasca is designed around that. High availability and clustering has been built in. It's a horizontally scalable and vertically tiered layered architecture. I'll show that a little bit later. And it's capable of long-term data retention, meaning that we don't just focus on the data that is a day old or a few days old. We're designed to handle and store your data for, in our case, 13 months or beyond if you need to. And that's really important. Maybe if you're a pure operator and you're just trying to keep services up, it's really not important to you. But if you're operating a cloud or you're operating a service, you might have things like SLA metrics or capacity planning and trend analysis metrics, or you might need to go back and do post hoc root cause analysis. Or if you're a data scientist, you might need to go back in time and look at things and do all sorts of analysis on it. So there's lots of other cases where data retention is important. Okay, and then finally, our system is designed to be extensible and composable. And just a couple words on extensibility. There's lots of ways to extend systems, but I mean extend it not only from external components, but extend it internally. and composable, meaning I can combine things together, and I can combine loosely coupled systems together and compose them and create some additional use cases out of that, or satisfy additional use cases. So before I get into my architecture pitch, because I'm trying to cater this talk to not just people that want to know what features are in Monasca, but people that might want to know about large-scale services, I got a few things to cover here. One is called The Log. And The Log was a famous blog written by Jay Kreps from LinkedIn. Jay Kreps is the creator of several very important pieces of software in the big data community. And one that he created was called Apache Kafka. So there's a link there. What every software engineer should know about real-time data's unifying abstract. I really encourage people that aren't familiar with that to check that link out. Jay Kreps has written a book. You can go read that book now as well. It's a fairly short O'Reilly series book. I don't know, like 150 pages or so. I could probably read it in a couple of hours. But I encourage people to get familiar with that. But there's a couple things I want you to take away from this slide. One is, what is a log? I'm not talking about your logging data. I'm talking about something called a log, which is an append-only, totally ordered sequence of records ordered by time. Okay, so that's what a log is. And in the context of Kafka, it's a distributed, highly available, durable, performant log. And that's used within Monasca, and I'll cover that. The other thing here is in the bottom, on the left and on the right, I got two pictures. And at LinkedIn, when they were first starting out, their infrastructure was looking like that, where we basically had a connection from every service to every other service in it. And they found out that that was really the bottleneck in their system. Not just a performance bottleneck, but a bottleneck in terms of getting things done, in terms of being productive. So when they created, so Apache Kafka was largely created out of that, and they went from that picture on the left to this picture on the right. And so they use Apache Kafka for storing all of their messages. And so you've got publishers of messages publishing into the log. And these publishers don't know anything about the consumer. So this is your typical message queuing type architecture. Only in this system, this is designed to handle millions of messages a second and billions of messages a day. You can only imagine what LinkedIn's infrastructure has to be designed to handle in terms of messages. So that's a very key concept, and that served, the reason why I put it up there is it served as some of the inspiration behind Monasca. Okay, we finally made it. And I'll have a few other architectural slides like that later on, but we finally made it to what is our architecture? Okay, and let me just check my time. 9:40, okay. Oh, there's a big clock up there, great. Okay, so the reason why I check the time is I can sometimes spend a half hour on this one slide and put everybody asleep. I don't want to do that today. And I got a lot of other slides to get through. So, all right, so this long horizontal line here, the Monasca API, that's basically our primary ingestion point. We have an optional agent up in the upper right there. By optional, I mean, as part of the Monasca project, we have our own agent. It's written in Python, and but you could use anything. It's just an HTTP endpoint. So we have a well-defined API specification that's out there. Anybody in the world can code to that. Okay, so this agent posts metrics to our API. Not shown in this diagram is that the agent gets a auth token from Keystone. So when it's submitting those metrics to the API, it has an auth token. And our API, it validates all of the incoming requests. And the next thing it does is it publishes to Kafka, which is our center box there. And so you got this metrics message or messages sitting on this metrics topic. Now, we don't have too many consumers here. and picture, have some diagrams later. We got a lot more consumers. But basically, that's the end of the pipeline for the API at that point. And so we've got our messages. They're stored in this thing called Apache Kafka. It's a durable message queue. It's performant. It's scalable. It's distributed. So, we've got your data. Okay. So then we've got components here. This persister one. And when I draw these boxes here, I've tried to show that these systems are running clustered or replicated within the infrastructure. So that's not just a single component that's running. Our usual deployments that we kind of focus on is usually on three physical nodes or servers. And that's why I've got 3 boxes, but it could be way more than 3. We've been looking a lot at containerization lately and looking at scaling out the number of containers that we're running. But so all these services are running, at least in this diagram, kind of shown in 3 physical computers. Okay, so getting back to the data flow here. So our messages come into Kafka. Our persisters consume those messages, and they buffer them in memory for a short period of time or the size of the batch. And then periodically they send them to our time series database. Our time series database, we don't create our own time series databases on our project. I would have loved to have done that, and sometimes I think I should have. But our 2 officially supported time series databases today are InfluxDB and Vertica. I'll go a little bit more into those later on. And those are fully clustered databases. Okay, so now our data is stored. Now we have this component here called the threshold engine. The threshold engine, and this is a microservices-based architecture. Our threshold engine is another component or microservice in this architecture. Our threshold engine's job is consume metrics, evaluate whether those values that we're receiving exceed some threshold, and if they do, publish a message back to Kafka. So it publishes alarm state transition events back to Kafka on another topic. Okay. Then our notification engine over here, bottom left, consumes the alarm state transition events, looks at them and says, should I send a notification, like an email, or should I create a PagerDuty incident? Should I send it HipChat or Slack? There's or a webhook or a Jira ticket, and we're adding more. Anyway, so that's what the notifications engine's job is, to create notifications from alarm state transition events. Additionally, the persister also consumes those alarm state transition events and stores them into our time series database. So we have a complete history of all the transitions in our alarms. And I didn't mention this, but alarms are the stateful resources in Monasca. Okay. Bottom left, our config database. That has the information about all the alarm definitions and alarms and notification methods. It has the state of all the alarms in there. Why are there 2 databases in our system? Some people ask that question, and so I'll answer it before the question's asked. Because some databases are really good at storing time series data and doing analytics, and other databases are good at more like transactional type stuff or storing records and updating records. Analytics databases are typically very, very bad at updates or deletes on data, and so if you have a record like an alarm that needs to be updated, you can't store that in your time series database. But MySQL, Postgres, those are really good at that more transactional type stuff. Okay. We have a couple ways of doing visualization. There's in OpenStack, there's something called Horizon. Horizon, which I'll show you later in the demo, is the dashboard that's used for interacting with all of OpenStack, and we have our own monitoring or Monasca panel that plugs into that. And then we also support Grafana. So we have a Monasca data source that was developed for Grafana, so that allows you to visualize all the metrics. Okay. Couple other things on this slide. So for querying data out of the system, that all goes through our API. And so upper left shows you can query metrics, alarm definitions, alarms, notification methods, everything else from the API. Okay, I've got a couple points later on this topic too. Okay, so Kafka, highly performant, distributed, durable, publish, subscribe, message, and stream processing system. If you're not familiar with that, there's some very good articles. I didn't put a link for that here, but check that out. So metrics, logs, and other events, so all the domain events for our system are published to topics in Kafka. Microservices register in a consumer group. Consumer group is a concept in Kafka as a consumer, and microservices subscribe to topics and consume metrics, logs, and events. Messages are replicated per consumer group. So in this diagram previously, if you had 3 persisters, you usually would have a persister consumer group. The messages are distributed across the persisters in there based on the key that is supplied. We use time as our key, so it's fairly uniformly distributed across all persisters based on time. At other points in the system, we can group on other keys, like something else that you might be wanting to group on, like a service name or something. Okay, so messages are replicated. Messages are load balanced. That's really important in all this. So if you're looking at designing a system to balance your load, Kafka is a nice point in the system to do that. And as microservices are added, or let's just say they die off, Kafka will basically, and I didn't mention this concept on this slide. I didn't want to go into all the details of Kafka, but for a topic, you're going to have your topic's going to be divided up into partitions, and if you add or remove these microservices from groups, they're going to redistribute those partitions across microservices. Okay, so basically you've got kind of true elasticity. Okay, so we guarantee at least once semantics guarantees on message delivery. So when you send a metric or log messages to our system, as long as it makes it to Kafka, and if it doesn't make it to Kafka, we tell you that. So you'd get an HTTP error in that case, but as long as it makes it to Kafka, and like the data center doesn't burn down instantaneously, then your data is guaranteed to make it into our database and to the threshold engine and everywhere else it needs to go. Kind of interestingly, we also use Kafka for storing our domain events. Domain events are things like when an alarm definition is created, we use it or delete it, or when a notification method is created. Those things. So Kafka is not only used for all this high streaming data content in our system, we use it for, it's become internalized into our application as domain events. And domain events, that comes from domain-driven design by Eric Evans. And so if you're familiar with that, that's what I'm referring to. There's a great YouTube video by Loggly. It was done a few years ago because they use Kafka and their logging as a service solution internally. And then you'll see something quoted there. Always accept data, never drop data, true elasticity. That's what Kafka gave them. That's what their main points are. Okay, command query responsibility. This is an architectural principle in Monasca, how we've divided up the pipeline. If you go look at this pipeline again, oops, there, okay. Data comes in, right, and then it's stored. So those are the commands, metrics, logs come into the system, they're published to Kafka, and they're written to the database. That's the command part. The query part of command query responsibility is the API querying things directly out of the time series database. A lot of people ask, well, why didn't you just send the data directly from the API into the time series database? And that would not be very efficient, and there's several other reasons for doing it this way. Okay, so there's a great link there. I know you can't read that, but if you're interested in CQRS, it turns out, as I was preparing for this presentation, that I was like, you know, so we have the CQRS architecture. I'm wondering if anybody else has realized how synergistic Kafka is with this. And so I Googled, you know, CQRS and Kafka, and I found this link from Confluent that was just published in September, which I thought was amazing. It's a really good presentation. And Confluent is the company that's basically trying to commercialize Kafka. They have support, they're maintaining it. Jay Krebs left LinkedIn and started up the company Confluent. But that's a very good article that'll really explain how Apache Kafka can be used in terms of event sourcing and CQRS. Okay, so microservices. Why do I call this a microservice architecture? So microservices are small, autonomous, decoupled services that are deployed independently and work together as a single application. That's what we have here. Each component in this system is kind of more or less single purpose, and they all communicate over a network using Kafka as the intermediary. And we can change services independently, and we've done that. So you can rewrite a service and drop it in, and as long as all you need to do is consume or publish messages from Kafka, you can the system will work the same. Some benefits of microservices: resilient scale, ease of deployment, organizational alignment, and optimized for change replaceability. Okay, so I kind of covered the post metric sequence. But basically, when you post a metric, it goes to our API, it's published to Kafka, a persister, process those metrics periodically, writes them to our time series database, and our threshold engine consumes them, evaluates alarms, and if they've exceeded a threshold, it publishes a message back to Kafka. I just want to touch on domain event sequence. So creating an alarm definition is one domain event in our system. It is, if some client creates an alarm definition, that is then stored and updated in MySQL. So that box there. And we also publish that alarm definition to Kafka. And then other consumers or microservices in the system can consume that. Our threshold engine would be very interested in that. Our threshold engine is a real-time, near real-time streaming threshold engine. It keeps everything in memory. So when it starts up, it reads from MySQL once, and from there on out, all it does is get these events via Kafka and updates its internal state. So that's how you get performance and scale to some extent out of this system. You wouldn't want to go to MySQL every time and query it and say, well, tell me about all alarms, and you wouldn't want to do that periodically. Okay, now to start speeding up a little bit. Okay, so deployment models, typically we're deployed in a clustered, there are many ways to deploy Monasca, but we're typically deployed in a clustered or high availability configuration. 3 nodes is more or less what we kind of focus on, but there's people that are deploying more than that. If any node or microservice fails, the cluster remains operational. Your data will be redistributed across Kafka and the remaining components. Preferably databases run on a separate 3 nodes or 5 nodes because there is contention at the drive level. Like if Kafka is writing lots of data to the drive and your database is writing lots of data to the drive, you're constantly seeking data on disk, unless you're in an SSD, in which case things can be run more or less on the same system. You can run Monasca on a single node. It's running right now on my laptop in a VM. non-clustered. And we're looking at containerization. Okay, this is our metrics model. So our metrics, this is a posting to the metrics endpoint that has a name called HTTP. The name in this case is called HTTP status. There's this thing called dimensions. In Prometheus, they're called labels. In InfluxDB, they're called tags. In CloudWatch, I think they're called dimensions. Everyone's got a different name. Essentially, it's a dictionary of key-value pairs. And so we have, in that regard, a similar model to some of these more modern monitoring systems. So the combination of your metric name and your dimensions uniquely identify a metric. We have a timestamp in milliseconds from the epoch. We have a float value. We have this other thing here called value meta. Value meta is used to supply additional information about the value. I don't think Prometheus has this concept in there. And sometimes people do this in the dimensions, but I like to keep it separate for various reasons. What this allows you to do is describe a measurement in more detail. If you're monitoring, if you're getting stuff from something that's purely binary data, or you've got some sort of categorical data, maybe it's okay, warning, critical, unknown status, like from Nagios. That was one of our use cases for adding this. And you've got a message associated as well, so you can supply that. So we have the metric value can be anything, but it could be like 0, 1, 2, or 3 in the case of Nagios. And so for okay, warning, critical, or known. And then you can use value meta in the case that you've got something that's warning or critical or known to supply additional metadata about that measurement. In this case, status code is 500, and the message is internal server error. One of the things we want to do, since we had Nagios, we had our metrics processing systems, we had monitoring as a service consolidate. And this more or less basically allowed us to replace the capabilities that we had in Nagios with Monasca. So I covered push versus pull a little bit, but just want to mention there's a few things that you can't do with pull. So you can't really do monitoring as a service with a pull-based system. You can put a proxy on top in front of things, but you can't, and that's a little bit different. But you can't always pull due to firewalls and network issues. You can push all the time usually, but you can't pull. You also can't do like low latency, sub-second response time in a pull model. So if you were trying to detect a VM going down or a container going down, and you want to do that in less than a second, sub-second latency, that'd be more difficult with a pull model. It's much easier to, when you do that detect, it looks like looking at process or a VM process. When that VM goes down, send a metric, and assuming your alarm system can handle that quickly enough, then you can process that. It doesn't require service discovery and registration, so when entities like nodes or services come online, they can just start sending metrics. There's no intermediary step. I can't handle events well, and one thing that we do in Monasca is if we can't reach the service, we temporarily cache metrics. By temporary, I mean maybe up to an hour or 2 or 4 hours. It's settable in the agent. Reason why we do that is if we're sending metering data into our system, we want to have all that data. The VM could have been alive for a tenant in OpenStack. We don't want to lose their data, even though the network might have been, the service, the Monasca API might have been unreachable. Okay. So a little bit about our API, primary point for publishing metrics. It authenticates all requests. Our primary resources are metrics, alarm definitions, alarms, and notification methods. There is a full API specification. It's horizontally scalable. And I'll move quick now. Persister. So we kind of covered what its roles are. It consumes metrics and alarm state transition events, and it publishes them. It consumes them from Kafka, and it stores them in our time series database. At least one's message delivery semantics. So basically, like if you were in the process of writing to the database, and then right after you wrote, you failed, or somebody stopped you or killed you, if you don't get a chance to update your offsets where you are in Kafka, since that's client controlled, then there's when you restart, you might read the same messages again. And we don't remove duplicates. We don't try to. And it's HA and fault tolerant. Okay, there's two databases, time series databases in our system for storing metrics or alarm state history. We support Vertica, and this is an open source conference, but Vertica is a enterprise class proprietary closed source HA analytics database. And we support InfluxDB, which is open source for single nodes. They unfortunately went closed source for their clustered solution April 4th, I believe, of this year. But there are some alternatives for doing that. InfluxDB has something called InfluxDB Relay, and you can also do a lot of things with Kafka, replicating data across multiple InfluxDB nodes, or partitioning data across InfluxDB nodes. And so we are going to spend more time on that. We're investigating, this has been a topic now for a while, investigating other alternative databases. We looked at Cassandra. We don't feel too strongly about that. And if anybody wants to know more, I can talk to them about that. And we're looking at Elasticsearch as well. Okay. So our config database, that was the one on the left, stores a lot of information in there about all the data in the system. Our threshold engine, this is our near real-time streaming process clustered and highly available threshold engine based on Apache Storm. Okay, so that's another Apache project. And that allows you to define a topology of computational elements. They call those elements bolts. So their terminology is a little strange, but they got spouts and bolts, but the bolts do the calculation. So we define this topology that's distributed across a cluster. And so that guarantees that we don't lose any data, and basically it evaluates if thresholds have been exceeded. It supports both simple and compound alarm expressions. And our notification engine consumes alarm state transition events, publishes or sends emails or SMSs or whatever else. There's a plugin design for the notification engine, so if you want to develop another plugin that's easy to do, we have SNMP in progress. And I've been feeling a little bit of Prometheus envy lately, so I want to add support for grouping of notifications in Monasca. Okay, our schema for our Kafka topics is published, and that's so that's not something that's just an internal thing that's used and it could change. It's something that's well defined. Okay, so we're going to get to the API. So you can create, query, and get statistics for metrics. Okay, so and those are so you can get all the metrics, all the unique metrics in the system. That's that top one. You can get all the unique metric names in your system, like CPU user %. You can get all the unique metric dimension names. Like a dimension name would be host name, region, cluster, service, component, things like that. You can get all those unique names, and then you can get all the unique values for those names with that last query there. And all those things are fully paginated. You can sort, group, filter on various aspects of them, and this is to guarantee that our user interfaces run very fast when you have a lot of data in your system. Measurements. pretty simple. Once you store all these measurements away, you want to get them out. You want to query them later on. So you can supply like a metric name that you're interested in, a start and end time. You got these 2 additional flags for merging metrics, different metrics together into a series or grouping them by various dimension names. So if I wanted to get all the measurements for CPU user percent for all of my VMs, I could specify a group by of like resource ID, because resource ID is something that's unique for a VM. And then I would get in one query, not just a single metric, I would get 10, 20, let's say I had 20 VMs. I would get 20 separate unique sets of measurements returned, all grouped by resource ID. Statistics. So if you want to not just get every measurement back, but you want to get the average and min-max summer count for those measurements back based on some period in seconds, like 5 minutes or 1 hour or 1 day periods, you can do that with our API. And you can also group by or merge those metrics together. Okay, so there's the API for getting metric names, dimension values. We kind of covered this earlier, and I got to start getting through my slides, which I'm a little bit behind. Alarm definitions, I want to touch on this. You don't create alarms in Monasca, you create alarm definitions. Alarm definitions are like templates or factories that are used to automatically integrate alarms based on some pattern matching that's going on. Our pattern matching is fairly simplistic. We pattern match exactly on the metric name and dimension name that has been or dimension name value that's been specified. But it turns out you can also do a match by clause here as well. And so if you specified an alarm and you said, I want to monitor all of my CPU user percent for all VMs, I would say match by resource ID. When metrics show up now that have CPU user percent as the metric name and resource ID as one of the dimensions, and that resource, the actual value of it differs, we automatically create alarms in our system. Right? That doesn't mean we start sending alerts out. That just means we create this stateful thing called an alarm. And then all metrics that subsequently show up will go to that alarm. Right? Alarms have states. They are tri-state, OK, alarm, and undetermined by default. You can also specify what we call deterministic alarms, which only have the OK and alarm state. The undetermined state shows up when metrics are no longer being received, right? So if you were monitoring a node for a long time and then that node disappeared, the alarm would transition to the undetermined state. And in some cases, you don't really want it to transition to the undetermined state. So if you're creating metrics from log messages, for example, then what you would end up doing is creating this deterministic alarm. And you only have those 2 states. So you can just send metrics when they're detected in log files, and when you don't find any errors, you won't have your alarms go to this undetermined state. They will stay in the OK state. Something also unique here, I should have put it in blue, thresholds can be dynamically adjusted on the fly. This is really useful if you got your system, you're monitoring a whole bunch of stuff, and you want to baseline the number of messages received or sent or the latency on your HTTP API. This is stuff that, dynamically, once you get your system up and running, assuming it sort of stays within some sort of mean, then you set those thresholds, and then at 2 a.m. if all of a sudden you're going beyond those thresholds, you can adjust those alarms without doing any code deployment or anything. Okay, so you can query alarms. You can say, tell me all the alarms in my system. We've got a lot of parameters that can be supplied to this. So you can basically query alarms and supply some parameters to filter on, like the metric names, states, or severities. the updated time or created time. And it's fully paginated, and you can sort by lots of different things for alarms. Okay. Alarm counts is another API we have. This usually shows up in dashboards where you're trying to, and I'll show you an example. The next page. So I don't know if you can see that, but in this case, we've got some dashboards being shown. We only got one alarm in the critical state for the compute service, and that's probably networking. And one out of 35, one out of 142. And if you want to show percentages and things like that, you'd have to do the calculations in your client, or in this case, the browser with some JavaScript. But that's what that query is about. And you can, when you're getting those counts, you can say, well, I want to group them by, like, again, a dimension. I can group them by a like service, in this case, is what they're being grouped by. And then I can also group them by severities or state. This is grouped by the service dimension and state, and then you can get your counts and do any math that you need to do. Like I mentioned earlier, we have our alarm history. That is all stored. So every time there's an alarm state transition, we store that. You can go back in time, look at all of your alarms. Really useful if you want to understand whether some service is flapping, or if you want to understand, like a month ago, what happened with this service. This looks like something that in the past I came across. Let me see if I can understand the patterns here. I can go back and look at my alarms. I can go back and look at those metrics, and I can start to figure things out, hopefully. Okay. Notification methods, these are the things that are created. They have a name, a type, and an address, email address in this example. Those are associated with your alarm state transitions. So when you go from OK to alarm, that's a alarm action. And when you go alarm back to OK, that's an OK action. You can associate notification methods with them, and those will be invoked by the notification engine. Okay, so our agent, it's a Python agent. It's optional. We monitor lots of stuff. There's no huge intellectual property here. But we do your normal system metrics. We do several services, MySQL, Kafka, and many others. We have a built-in stats daemon to our agent. So if you want to do instrumentation of an application, you can do that. We have our own library that adds support for dimensions in agents as well. We monitor VMs. We monitor Open vSwitch. We can do active checks like HTTP status checks, system up-down checks. We can run any Nagios plugin or CheckMK script. It's extensible, it's pluggable, additional stuff can be easily added. We've been in the process of adding support for Docker and Kubernetes and Mesos lately. And I'll have more in that detail. Just a couple of fine points here. I love to always cover the fine points. So the main point here, other than the authentication. So our agent authenticates a keystone. So when you deploy the agent, you have to supply it the username and password of your account. And then it requests those auth tokens from Keystone. And then that third bullet was the one I mentioned earlier. It will cache data if it can't reach the API for some period of time, so you don't lose data in our system. And that's important because we're not just handling operational data. We're handling data for the customer that we have a service level agreement with that says, we got all your data for 2 weeks or 4 weeks sometimes. There are roles within OpenStack, and we use them in Monasca. So the agent can't query alarms or delete alarms. The only thing it's allowed to do is post metrics. So we think we're fairly secure. All right. We have Grafana integration. I'm going to try to get to my demo the last 5 minutes. We have a Monasca data source. We also do Keystone authentication. and when Grafana 4 is out, or maybe it is out and I don't even know, but when it's out, we'll add support for alerting. There's a screenshot of our Grafana support. Okay, so logging. Logging is similar to the architecture is similar, and that's in part why we did this. But Monasca isn't just about monitoring as a service, it's about logging as a service. And the best way to think about that is probably to think about Loggly. But we have a logging API, and we've got several. In this case, we didn't have to develop our own plugin. We leveraged Beaver and Logstash. We have our own, I forgot the terms that they use, but our own plugins to those agents that post to our API. They do the authentication. They post the API. The concept is the same. Log messages are published to Kafka. In this case, we didn't write as much code. We leveraged Logstash a lot, but Logstash consumes those, parses them. We store that data in Elasticsearch, as it turns out, and that's the database down here on the left. And then Kibana is used to query that data out, and we have a modified version of Kibana that authentication, keystone authentication, has been added to it. So those are, I mean, the main points that of change here. The Kibana stuff has changed to add the keystone authentication and filtering based on token, by tenant ID. And then the output plugins have been created, and there's been some development in the Logstash components. I won't get too much into our logging API, but the same dimensions concept is there as well. So we can enrich log messages with these dimensions the same way that we do for metrics. And that's very useful for filtering and sorting and ordering and grouping things on by later on. Okay, where am I? Mentioned that. Composability. So one thing that Monasca allows you to do is compose systems together. We do that via Kafka. One thing that we want to do was create metrics and alarm and notifications when error messages occur in log files. And the way that works is on the left here, our logging infrastructure can create metrics and publish them back to the same metrics topic that all the other metrics are showing up on, which means that they're stored in the database, and you can alarm and threshold on them, and you can send notifications on them. Okay, so that's just a bit of the composability story around Monasca. Okay, so microservices, extensibility, composability. This slide is a little different than the earlier slide that I showed. We've got two new components here. One is this transform engine. It's really a transform and aggregation engine, and its role is to consume metrics and aggregate them. We can aggregate them in many different ways. It's mainly focused on capacity type use cases today, but we can take metrics coming from different physical hosts and aggregate them. Usually we want to aggregate them like for my overall deployment, like data center wide, or I want to aggregate them in the metering billing cases per tenant and tell them how many bytes they're using in the object storage system in OpenStack. And this component, I mean, it's totally optional. You can add it, drop it in and use it or not, but all it does is consume metrics and publish metrics. And the analytics engine is a little different, but the analytics engine is focused on doing more complicated things with metrics and alarm state transition events like anomaly detection and like what we call alarm clustering. The best way to define that is like what MoogSoft and Big Panda is doing, but taking a bunch of alarms and grouping them together based on some criteria, like some similarity type criteria. So I'm going to skip over those two things. We have a large number of distributions and deployments out there. Charter Communications is probably our number one user of Monasca. They run OpenStack internally in their private cloud. And they're using Monasca and Grafana. And they're not just using it for operational monitoring. They're doing the true monitoring as a service. They're actually the ones that added Monasca data source to Grafana. They got 2 data centers, 600 to 700 compute nodes. Total, that number seems low, 1,000 VMs. They're processing a fairly low number of metrics. They're very careful with their metrics. They don't just throw all the metrics at the system that they can. They've been very picky, and so they have a fairly low metrics number, which is good. Firewire Lab, if you look at that link there, you could see what they've discussed, what they've deployed. There's Hewlett-Packard Enterprise, where I'm from, and we're using it in our cloud system and OpenStack projects. And can I go another 5 minutes, or? Okay, good, good. Just making sure. And Fujitsu is involved in the project, NEC is involved, and others, and we've all got points out there. Some various statistics. We've got 31 organizations, 97 contributors. In the past, I guess, year, 1,075 commits, 4,080 reviews. And that's the ecosystem around us. So Charter, NEC, Cisco, cloud-based solutions. SUSE, I put them on, they're green, but that's kind of new to Hewlett-Packard as partnerships. So I'm sure they'll become involved. They're not quite involved yet, although. And then there's SolidFire, SAP. Fujitsu and SAP, by the way, are here in Germany, and I stopped and visited Fujitsu in Munich on Monday and Tuesday this week. Cray, Fireware Lab, Mirantis, and Broadcom. So I think I'm going to end the slides there, and I can do a very, very, very quick demo, or I can take Q&A. Because I only got a couple minutes back. Demo, okay. All right, so how does this work? All right, this is Horizon dashboard. This is OpenStack dashboard. All right, so I'm logging into that, and what's new here is this monitoring panel that we've added. If I click on that and go to the overview page, there's not a whole lot there right now since I haven't created any alarms yet. And I can go into Grafana, and you'll notice there's a logon page. If you're looking at Grafana today, you won't see that. And we can log into Grafana. So we've basically made Grafana a multi-tenant system. We have Monasca, and it's been added as a data source into the system. So if I click on that, and I can save and test that, and data source it's there. And I can come in, I've got a dashboard, and there's my demo dashboard. And I created this earlier. This is just monitoring the CPU user percent of the VM that I've been running on this system. So I can go add a row to this, and we'll add a graph row, and then we'll edit that. And we can go look for like other metrics, disk, that's not a very useful one. Let's just go make another CPU user percent one. I'm not feeling very creative today. And we've got these functions here, so that's currently average. I'll say none, and it updates. We can specify dimensions here. There's not too many dimensions in this system, very small system. I can select host name. I can say that the name of the VM is DevStack, and there it is again. Okay, so what else is interesting here? I can create alarm definitions. We're going to create an alarm definition. We'll call it CPU utilization. Description will be description. And severity, we'll give it medium severity. We'll click next. And we'll give it an expression. So the expression will be if the average of my metric, CPU.user %, the comparator is greater than, we're going to make sure that this thing fires. So greater than 2, this thing is going to go off. So, and we won't give it any notifications. Okay, so we'll create that. And away it goes. Okay, so we'll come back to this overview page, and in a second, we will have an alarm that's been created. Remember, we create alarm definitions, and we do pattern matching. When the metrics show up, we see the alarms being created. So there were 2 boxes added there. This panel is just displaying. There's actually a dimension called service, and in this case, its value is monitoring. But we've got really one alarm, but they're being grouped different ways. The top row is grouped by service, and the bottom row is grouped by server. In this case, it's my VM. The VM name is DevStack. So I can go look at the alarms, and there it is. And it's in this undetermined state because I said the average of this metric over time, and we don't have enough values to actually evaluate that average yet. So this will transition to probably the warning state in a minute or 2, which I'm not going to have time to show, apparently. That's basically everything I have for today then. A really short demo, but gives you a flavor of what we've done in terms of integration with OpenStack and what the capabilities are in the user interface and what Grafana can do. I didn't show any Logstash or Kibana running, but you can do similar sorts of things with logging messages there. And that's it. Thank you, everyone.